Let's take a look at 85D, one that we're going to use integration by parts, but this is a definite integral. So how do we do definite integrals? Well, I mean, we could just get rid of the limits of integration, use integration by parts to find the antiderivative, and then evaluate using the fundamental theorem of calculus part 1. I'll kind of just merge the processes together and show you how that works. So here again, don't forget, what do we choose for our u and dv? We have an x, cosine of pi x. So we're multiplying those two together. Well, remember the acronym LIATE, we look for log functions first. I don't see any inverse trig. I don't see any algebraic. I do see x is algebraic, so I'll let u be x. That leaves dv to be everything else, the cosine of pi x dx. Differentiate x, I get 1, so du dx is 1, so du is equal to dx. Integrate, right? Integrate dv, we get v. Here we have to integrate, and I've done this in my head. Hopefully you can do this substitution in your head. If not, if you let u be pi x, that means du is pi dx. So 1 over pi du is equal to dx. That's where this 1 over pi comes in. Antiderivative of cosine is sine, and so there's the antiderivative. All right, so if we remember how the integration by parts formula works, it is the integral of u dv is u times v minus the integral of v du. And so I've got my uv x times 1 over pi sine pi x is this. But then notice, since this is definite integral, I want to evaluate this, right? I put my evaluation bar at the upper limit of 1 and the lower limit of 0, minus the integral of v du. So 1 over pi sine of pi x, and du is just dx. So I pull that 1 over pi out. Of course, again, I've got my limits from 0 to 1. All right. And now in evaluating this one, I'll plug in the upper limit 1. I get 1 sine of pi. I pulled out the 1 over pi out completely, minus the evaluation at 0. I get 0 times sine of 0. Well, 0 times anything is 0. So notice that sine of pi is equal to 0. So it turns out that this whole expression does indeed go to 0. Okay. Over here, we're going to do the integration first. So I got the 1 over pi comes out. What's the antiderivative of sine of pi x? Well, again, it's a simple substitution. If u is pi x, du is pi dx. And so 1 over pi du is equal to dx. So here's the 1 over pi. The antiderivative of sine is negative cosine. And so we get this as our antiderivative using a simple substitution. Okay, and you should check. You should be able to quickly take the derivative of this using the chain rule and get back to the original sine of pi x. Okay. So this is all 0. Here I'm going to evaluate. I'm going to pull out this negative 1 over pi out. So negative times a negative is positive. 1 over pi times 1 over pi is 1 over pi squared. Then I've got cosine of pi x, where x is 1. So cosine of pi minus evaluation at 0, cosine of 0. Cosine of pi is negative 1. Cosine of 0 is positive 1. Negative 1 minus 1 is negative 2. Multiplying, I get negative 2 divided by pi squared. So just be careful when you're using integration by parts on a definite integral that you indeed evaluate the uv, right, portion of our integration by parts formula, the uv. So in other words, if I'm integrating from a to b of u dv, I have to evaluate the uv, right, the upper limit b minus the lower limit a, and then do this integration with the fundamental theorem of calculus. Okay. So I hope this helps clarify these type of problems.